Today we're going to look at a review for the test that we're going to take tomorrow. Today we're going to look at a review for the test we're going to take tomorrow. So, this is not going to be turned in. This is not for a grade. This is for you to use to study. So anything you need to write down so that you can make sure you understand everything that we're doing, that's what you should be writing down. Okay? All right, so number one, it says to refer to the picture. It says name a line that contains both points T and P. Okay? So when I look at where T is, I'm going to zoom in. When I look at where T is and when I look at where P is, and I want to name a line that contains both of those, okay, I can see that if I look at that line, there's a little lowercase g on the end of it. So I know I can name that line G with a little lowercase g. That's not the only thing I can name it. I could not even look at the picture and I could say, well, if it contains both of those points, then I could call it line TP. As long as I use a capital T, a capital P, and put a little line symbol above it. Or I could call it line PT, because the order doesn't matter. Or I could look at that line and I could say, well, there's also on that line, there's an N. Right? On that same line, there's an N. So I could also call it NT. Or TN. Or NP. Or PN. Now, if it says to name a line that contains points T and P, you only have to give me one of those options, but again, I want you to see that there are multiple correct answers for this one. Okay, name a line that contains points T and P. All of those are correct names for that line. Okay, any questions on one? All right, on number two, we're going to name a line that intersects the plane containing Q, N, and P. So if I look at Q, I look at N, and I look at P, those are all in plane S, right? They're in that rectangular or parallelogram-y shape. They're all in that plane. So which line intersects that plane, goes through that plane? J, right? I can tell because it's dotted right there, so that means it's going underneath the plane right there. So line J, lowercase j, is the name of that line that intersects the plane that has those 3 points in it. Okay? Is that the only thing I could name that line? No. What else could I name that line?
MT.
MT. As long as I use capital M, capital T, and a line symbol, what else?
TM.
TM. Anything else? No, those are the only 2 points. I can't use the J because that's not a point. So I can't say JM or JT because J is not a point. To name it like this, they have to be points. Okay? Number three, name the plane that contains line TN and line QR. What's the name of the plane that contains line TN? So here's T, here's N, so that's this line. And QR, here's Q, here's R, so that's this line. What plane contains both of those lines?
S.
Plane S. Capital S. And I know that S is the name of that plane because there's no point next to it. There's not a point next to S, so that must be the name of the plane. Is that the only way I could name that plane?
No.
No, I could pick 3 points that are not in a line and use those 3 points to name the plane. So I can't call this plane PTN because those are all on the same line. But I could call it plane PTR or QPN, right? Any 3 points that are in the plane that are not in a line, I could use. It's a longer list than I want to list out, so I'm not going to do like I did for number one and list them all out. But just remember they cannot be in a line, and they have to be in the plane. All right. Number 4 through 7, we're going to be looking at this picture here. I don't know if I can get it to show up underneath, but I actually have a 3D representation of that exact same thing. Okay? So here, right, I have plane W and A, B, C are on the bottom. A, B, and C are on the bottom. And then I've got ED up here. And then I've got FE over here. And then FD back here. Okay, so this is just the actual like 3D representation of this picture, because sometimes that's helpful. I know it's really little on there now, but this first one says, how many planes are shown in the figure? Because, you know, planes can be invisible, so there's really like an infinite number of planes here. But the number of planes that are shown in the figure, how many flat surfaces are there?
6.
6? Let's see. I've got the top, right?
5.
I'm hearing 6 and 5. I've got the top. I've got the 3 sides. And then I've got this plane that points A, B, and C make up the bottom of both the prism and the plane together. So that's really only 5 planes. Yes? Yes, you may. So there are 5 planes shown in the figure. Okay? All right, I know this is really little, but it says how many of these planes, so how many of the shown planes from number 4, how many shown planes contain both the points F and E? So contain both the F and the E. So this corner here and this corner here, how many shown planes have both of those points? 2, right? Because the top, F and E, are both in the top corners. But they're also part of this side here, right? So F and E are part of this top plane, but they're also, it's hard to see that I shaded that in, they're also part of this side plane. So there are 2 planes in the picture anyways that contain both of those points, right? There's really an infinite number of planes, but the ones that are shown in the picture, there's just 2. Okay? Name 4 points that are coplanar. What does it mean to be coplanar? On the same plane. So I need 4 points that are on the same flat surface. Yes?
A, B, C, D.
Oh, yes. A, B, C, D. E. A, B, C, D. Now here's the problem. If I do A, B, C, you say E or D? Which 4 points did you say?
Wait, the D like on the 4?
4 points have to be all on the same plane. Yes, Sean?
F, E, A, B.
F, E, A, B. So if I look here, I can see that F, E, A, and B are all on this side. So F, E, A, and B, these 4 points, F, E, A, and B, they're all on this side. So yes, point F, E, A, and B. We don't have to put them in any sort of order because we're just listing points, right? We're not naming anything. F, E, A, and B. That's not the only answer I could have given, but those are all on the same plane. But I could have looked at any of the sides, right? I could have looked at this side and said D, F, A, and C. Those are all on the same plane. They're all on the same flat surface. Or I could have looked over here and said E, D, C, and B. Those are all on the same side. So those are coplanar. They're all on the same plane. Okay? Questions on naming points that are in the same plane? Okay. Are points A, B, and C coplanar?
Yes.
I don't even have to look at the picture. 3 points are always coplanar no matter what. Yes. Any 3 points are, I'm going to zoom in now because we're done with the 3-dimensional figure. Always coplanar. So I could have even said, I know it's not going to look like it in the picture, but if I said are F, E, these 2 up here, and C coplanar?
Yes.
Yes. even though in the picture I don't see them in the same plane, I could build a diagonal plane through that picture that would connect those 3 points. 3 points are always coplanar. 3 points are always coplanar. Okay? All right. For 8, 9, and 10, we're going to be using the segment addition postulate. Good. And that says the left side plus the right side, if you have a horizontal segment, equals the whole thing. The left side plus the right side equals the whole thing. So when I look at this first one, the left side is 23. The right side is x. It equals the whole thing, which is 56. What am I going to do to solve this? Yeah, subtract 23 on both sides. So then x equals, what's 56 minus 23? 33. Okay. Number 9, the left side plus the right side equals the whole thing. The left side is 3x plus 7. The right side is 2x. It equals the whole thing, 47. What am I going to do first? Yeah, combine like terms. 3x plus 2x is 5x plus 7 equals 47. What's next? Yeah, what do we call that property? Subtraction POE, property of equality. So 5x equals 40. Then what? Division, property of equality. And what does x equal? 8. X equals 8. Am I done? No. What should I still do? Check your work. So 3 times 8 is 24 plus 7? 31. 2 times 8 is 16. Does 31 plus 16 equal 47? Yes, we can feel confident that x really does equal 8. Okay, next. Number 10, given k is between j and l. Does that mean it's right exactly in the middle? No. So when I draw my picture, if I see the word between J and L, when I draw my picture, I'm going to intentionally make sure K doesn't even look like it's in the middle, because I don't want to accidentally get it confused with a midpoint, right? So now that I've got K somewhere between J and L, not necessarily in the middle, now I'm going to read my next sentence, my next given. JK equals x plus 4. So from J to K is x plus 4. K to L is 6. J to L is 2x. The left side plus the right side equals the whole thing. What's my left side? Plus, what's the right side? 6 equals, what's the whole thing? 2x. What should I do first? Okay. X plus 10 equals 2x. Now what? What are we going to subtract?
X on both sides.
Yeah, because we're not doing a proof, so we don't care if x stays on the left side or the right side, so let's keep things positive. 10 equals 2x minus x is? X. Am I done?
No, we need to substitute that.
Okay, so if you plug it in to check it, if I put a 10 in here, 10 plus 4 is? 14. That we already know is 6. If I put a 10 in here, 2 times 10 is? 20. Is 14 plus 6 20?
Yes.
Yes, we can feel confident that we can put a box around our answer. Number 11, using the diagram for number 10, find JK. We already did because we already checked our answer. What was JK? 14. What's KL? Yeah, we already know that's 6. We don't even have to do any math for that. And then JL is 20. Because we already did that when we checked our work. Easy peasy. Questions on anything on the front side of this review? All right, let's look at the back side. Ooh, distance formula. You do not have to memorize the distance formula. I will give you the distance formula. Okay? When I do the distance formula, the first thing I do is I write it without the x's and the y's. I do write the square root so that I don't forget at the end to take the square root. Okay? So I do a parentheses. I leave a space for x2, minus, leave a space for x1, close parentheses, squared, plus parentheses. Leave a space for y2, minus, close parentheses, squared. Oh, leave a space for y1. I forgot to say that. All right. Then I label my points x1, y1, x2, y2. It doesn't matter which one you call point 1 and which one you call point 2. Usually whichever one they give me first, I call my x1, y1. And the one they give me 2 is my x2, y2. But you could switch it around. You'll still get the same exact answer. Okay? I did have some people do some weird things when they were doing their actual assignment when I was grading this one. And some people labeled the first point x1, x2. And then they labeled the second one y1, y2. A point has to have an x and it has to have a y, right? So they're both going to be x and y, x and y. These have the 1s because it's the first point. These have the 2s because it's the second point. All right, so now I just fill in, right? Now it's like when you were a kid and if you had that little red and blue ball and you had to put the yellow shapes in the right space. You know what I'm talking about? Red, and you put like the triangle goes in the triangle hole and the square goes in the square hole and the circle goes in the circle hole. That's all this is. This is like a toddler's little shape toy. You just put the right shape in the right space, right? So the shape that goes with x2 goes in the first hole, right? So x2 is 5. x1 is 0. y2 is 12. y1 is 0. Just fill it in, and then from there you simplify. Okay? So my distance equals the square root of 5 minus 0 is 5. Plus 12 minus 0 is 12. Notice I still put it in parentheses because sometimes when you do that subtraction you're going to get a negative number, and it's important to remember that that negative number, the whole thing needs to be squared, right? If we had switched those 2 points around, I'd have had 0 minus 5 and I'd have had a negative 5 here. If I had 0 minus 12 here, because I switched the points around, I'd have a negative 12 here. But we need to remember what happens when I square a negative. I'm going to get a positive. You ever get negatives when you're doing the distance formula? You forgot your parentheses, and you forgot that when you square it, it becomes positive. Because whether it's a positive 5 or a negative 5, when I square it, what do I get? What number do I get when I square the 5? I get a positive 25. Whether it's a negative 5 that I'm squaring or a positive 5 that I'm squaring, I'm going to get a positive 25. Plus, what do I get when I square 12? 144. Be careful. Some of you accidentally doubled instead of squared. Right? You multiplied by 2 instead of multiplying by itself. So then, when I square root, I add these together. 4 and 5 is 9. 4 and 2 is 6. What do I get when I do the square root of 169? 13. When I take the square root of 169, I no longer write the square root. Those of you who have already had Algebra 2, they taught you when you take the square root, there's 2 answers. It's positive 13 and it's negative 13. But why don't we care about the negative side? Because what are we finding? We're finding distance, and distance is always right. It's never negative. Even if you're going backwards, it's always a positive distance. So we don't care about the negative solution. We only care about the positive solution. Okay? All right. Number 13, same exact process. Okay, this time we get to deal with some negatives. Okay, all right, so distance equals the square root of parentheses minus parentheses squared plus parentheses minus parentheses squared. All right, and then we label our points x1, y1. x2, y2. And then we just fill in. x2 is 2. x1 is a negative 3. I already have the minus in there, but I still need to put the negative with the 3. y2 is 7. y1 is negative 1. And I have the minus in there, but I have to fill in the negative 1. The reason it's good to do the formula and then fill it in later is because that's going to help you catch when you need to do what? When you need to take care of your double negatives, right? And you really are going to be adding here, not subtracting. So I'm going to end up with distance equals the square root of 2 plus 3, which is 5 squared, plus 7 plus 1, which is 8 squared. So my distance equals the square root of 5 squared? 25. Plus 8 squared? 64. So my distance equals the square root of 89, which, let's see, the square root of 89 is not something I know off the top of my head. Don't save the old one, get a calculator. The square root of 89, we're going to round to 3 decimal places. So when I look at this, I see 433. Check after the 3, and it's a 9. So do I round up?
Yes.
Yes. So it's 434. 9.434 is my distance.
Will we have these on these equations on like a sheet of paper?
Yes, you won't have to memorize the distance formula. I will give you the distance formula tomorrow. You will not have to memorize the distance formula.
Thank you.
You are welcome. All right, midpoint. Right exactly in the middle. I gave you 2 methods. I gave you the average method and I gave you the column method. For the average method, you average your x's, you average your y's, right? And there's 2 x's and 2 y's. You add them, divide by 2, right? So to find the x of the midpoint, we take our 2 x's, 1 and 6, add them together and divide by 2. What's 1 plus 6? 7. Divided by 2?
3.5.
Yeah, 3.5. It's okay to make it a decimal. I'm okay with that. As long as it's a nice even terminating decimal, which the average always would be, then you're good. Then I do the same exact things to find the midpoint, the y value of the midpoint. I've got a 2 and a negative 6. So 2 plus a negative 6 divided in half. 2 plus negative 6? Negative 4. Negative 4 divided by 2 is negative 2. So the midpoint, I'm going to put M for midpoint, is 3.5 negative 2. Okay? And I had also shown you what I call the column method. It's my own like little invention. So if you don't like actually averaging, and this one actually works better if you need to find the end point, which you might need to do tomorrow, is to write your 2 ends, 1, 2, and 6, negative 6. Or if you know your midpoint, then you would write your first point, your midpoint, and then leave the bottom one blank, right? And then if you know the first 2, you just see how does this change, make that same change. How do these 2 change, make that same change. To find the one in the middle, you have to look and see, well, how far is it from 1 to 6? It's 5 units different, right? So half of 5 is 2.5, right? 2.5. So if I increase by 2.5, half of the 5, I end up at 3.5, which is what we had. right? Over here from 2 down to -6, from a +2 to a -6, that's a decrease of 8. Half of 8 is 4, so decrease by 4. 2 minus 4 is -2, which is what we got there. So it's just another way to do the exact same thing. I think they're both pretty similar in how easy they are when you're finding the midpoint. I think this one is way easier if you're finding the other endpoint. Because then you just go, oh, there's a difference of 4, so go down 4 more. Right? There's a difference of 2.5, so go up 2.5 more. Okay? Questions on 14? All right, let's look at 15. Find the point that is 1/3 the distance between 1, 1 and 10, 13. So if I were to sketch that graph, everything's positive, so I'm going to make it like a positive graph. I'm just going to kind of make myself a little sketch because for me personally that's easier. If I can see if I'm going left or right, I can see if I'm going up or down. And I know 1, 1 would be close to the origin. 1, 1. And then 10, 13, right, if I go out to 10 and I go up to 13, 10, 13 is going to be like somewhere up here. So I want to know where is 1/3. So if I was to take this segment and like divide it into 3 equal pieces, 1/3, and it didn't tell me which point I'm starting at, so that means I'm going to be starting from the first point they gave me, because they didn't specifically name 1A and 1B and then say from A to B or from B to A. So I'll be going from the first point. So if I want to go 1/3 from the first point, that would be, I'm trying to find this point right here, right? 1/3, 2/3, 3/3. Trying to figure out what that one is. First thing I'm going to do is find X. And I'm going to do the exact same process that we did yesterday for the number line and for the graph. So the first thing I need to do is look on my x-axis. I can see I'm going from 1 to 10. How far did I travel? 11? 9. Right? I went, here's the origin all the way to 10. I went all of that except for 1. Right? So that's really 9. I don't want to go that whole 9. I only want to go 1/3 of that 9. What's 1/3 of 9? 3. So then, if I'm going from this point to this point, I'm going this direction. Am I adding or subtracting?
Adding.
Where am I starting at? 1 or 10? 1. So 1 plus 3. The answer we got from there. So I'm going to be increasing by 4, or I'm increasing by 3, and I end up at an x value of 4. So this x value here is 4. Okay? Then I'm going to do the exact same process, but this time with my vertical axis to find y. So this time on my vertical axis, if I'm going from 1 to 13, how far am I going? 12. I only want to go 1/3 of that. 4. I'm starting down here at 1. I'm going up, so is that increasing or decreasing to 13? It's what? Increasing. I'm increasing by how much? By how much? 4. 1 plus 4 is? So y equals 5. So the point that I'm trying to find is the point 4, 5. What's kind of neat is I could find that other third by just increasing by the 3 and by the 4 again, right? I increased from 1, I added 3 to get to 4. If I add 3 more, 4, 5, 6, 7, and then 7, 8, 9, 10. If I wanted to find, so that would give me my 2/3, right? If I wanted to find the y value there, each time I'm going to increase by 4. So from the 1, I went up 4 units. That gets me to 5. I go up 4 more units. That gets me to 9. Oops. And then if I go up 4 more units, I'll end up at 13. Okay? So now I've also kind of showed you where 2/3 from 1 is. Okay? All right, now we get to do some fun drawing. Are you ready for drawing? Yay! Sure. Okay. 16, point K lies on RT. What should I draw first? RT, the line, right? It's a line. It's got 2 arrows on each end. You can draw a line going vertical, horizontal, uphill, downhill, whatever line you want to draw. How do I put the RT on it? Do I just go and put an RT by an arrow? No. Do I put an R at one end and the T at the other end? Would that be right? No, that's not right. That R and the T aren't labeling arrows. They're labeling what? Points. Big hint. If I ever write something in pencil and ask you, is that right? The answer is probably, because I plan on erasing it. Those points have to be somewhere on here. Doesn't matter. You could put them real close to each other if you wanted to. And name one R and the other T. But the T and the R have to be attached to points. They can't just be labeling the arrows on the end. If you're labeling the arrows on the end, it's with a little lowercase letter. Okay? I could put those T and the R in any order anywhere on the line. And then what else do I need to add to the line? Point K has to be somewhere on the line. Does it matter where I put it? No, I could put it way up here if I want. I could have squeezed it in between T and R if I wanted to. I could put it to the left of T, to the right of R. It doesn't matter where I put it as long as it's somewhere on that line. So all of our pictures could look different, right? And that's okay. Number 17, plane J contains line S. What should I draw first, do you think? The plane. So when we draw a plane, we draw like a little parallelogram. How do I show that it's plane J? I do what? A J without a point. Does it matter which corner?
No.
Whichever corner you like the best.
Does this be capital, right?
It's going to be capital. It'll never be a lowercase for a plane. The only thing that ever gets a lowercase is going to be a line that's not being named by its points. So for example, this one says line S. Notice that S is a lowercase, right? So when I draw line S, I need to make sure it doesn't leave the plane. So these arrows can't exit the edge of my plane that I drew, because it has to stay inside that plane. This time that S, do I attach it to a point?
No.
No, why not?
It's the line.
It's the name of the line. It's a little lowercase. So it can either go by this arrow, or it can go by this arrow. It doesn't matter. Okay. Questions on 17?
No.
All right, let's look at 18. Line YP lies in plane B and contains point C but does not contain point H. What should I draw first? The plane. Let's draw the plane. And I usually tilt mine to the right, but you can tilt it whatever direction you want to tilt it. A plane could even look like a rectangle. Does it matter where I put the B? No, your favorite corner. Today, that's my favorite corner. Kind of looks like a little heart the way I did it. Then what? The line. Can it go outside my plane?
Yeah.
I heard a yes and a no. Which is it? No, it has to stay inside my plane because it says lies in the plane. So when I draw the arrows, I can't extend them past the edge. How do I label it YP?
Put the points on the line.
Put points on the line and label the points. Capital Y, capital P. It's hard to tell with Y's and P's if they're capitals, but do your best. Contains point C. Where do I put point C?
On the line.
On the line. Does it have to be in a specific place on the line? No, you can put it to the left of Y, in between Y and P, to the right of P. Wherever you want to put it, that's where you should put it. I'm going to put it real close to P, just because I can. What about point H? I haven't figured that one out yet.
It's not on the line.
It's not on the line. Can it be in the plane?
Yes.
Yes. Can it be outside the plane?
Yes.
Yes, because it doesn't tell me whether it's in the plane or not. So I can either put it in the plane, or I can put it out of the plane. Completely up to you. We can all do it different. I'm going to go ahead and put mine in the plane. Point H. I think in the last class I put it outside the plane. You. Okay. And last but not least, number 18. Lines Q and F intersect at point Z in plane U. What do you think I should do first?
The line.
The plane? Okay. I think the plane is easy to do. I know I'm going to be having two lines in it, so I'm going to make a nice big plane because I got room for it, so why not? What's the name of my plane? U. I'm going to put it up here because I can. Nice capital U. Then what?
Line.
How many lines?
2.
2.
And an X.
And they're intersecting, right? So like in an X or something. It doesn't tell me how they're intersecting, so I don't know if it's perpendicularly or not. All right, and then one is line Q and one is line F. How do I label them?
Lowercase.
Lowercase by an arrow, right? It doesn't matter if I put the Q at the top or the bottom or where I put it, as long as it's by one of the arrows. And then the little lowercase f has to go by the other one of the other arrows on the other line. And then where do I put point Z?
Is the intersection.
Right at the intersection, right where they cross each other. Capital Z. Any questions on anything on the review? Okay. All right. You also picked up when you came in a little green card. This little green card, you can write whatever you want to on this card and use it on the test tomorrow.
Oh my goodness.
So if you write real little, lucky you. If you write real big, both sides. Whatever you can fit on this card, you fit on this card. You will have to staple it to your test tomorrow and turn it in if you use it. Whatever you fit. So the remainder of the period, you can be filling out whatever you want to put on your green card. Okay? And you can use it on the test tomorrow.
Cut out a piece on the paper and then put it down.
I mean, I guess.